So, couple of things about this week. First off, we'll start with today. You should have grabbed a homework packet as you came in. For sure, right now, you can do numbers 1 through 8. Probably even after today, you can go a little further on those if you want. Okay? Then let's talk. So then later on, so notes today are going to be in your note packet. We're going to hammer out a bunch of notes today in that, and so we'll be in that for today. Tomorrow you're going to take a formative, okay? So you're going to take a formative on just on navigation angles type of stuff, not the stuff that we're doing today. Today's stuff will not be on the formative, but last week's stuff will be on tomorrow's formative. Okay? Then we'll have some notes tomorrow also. And then Friday is Pi Day. Okay? So we are offering an extra credit opportunity since we love pies and it's Pi Day and we use pie every day. So we are offering you a chance to bring in a pie for your classmates to share on Friday, Multiple Forces Pi Day. Okay? That pie that you bring in will be judged on 4 different categories. It's like a pie competition at the county fair, but here in Precoat. Okay, the first qualification or the first judgment will be on taste. How does your pie taste? The second one will be on quantity, meaning if you bring in one of those little mini pies versus an actual full-size good pie. Okay? Second one will be creativity. Okay? So we'll have creativity in there. There's many different things that you could use to decorate your pie or come up with flavors for pie. And then the third or the last category is going to be quality. Okay? Now quality is going to be, I can guarantee you that if you go to County Market tonight and buy a pie, or tomorrow night and buy a pie, you will get a 1 in quality out of 10. Okay? Whereas people that make their own will be on the 10 side. Okay? If you do a homemade pie, you will score a lot higher in that one. It's even written on the thing, store-bought versus homemade. Store-bought is by 1, homemade by 10. Okay? Okay? So that would give you then a chance at 40 points. Okay? We're going to divide whatever total you get out of those 4 categories by 10. That will give you the points that you get back. So you have upwards of 4 points, where we also might throw in a bonus 5th point or something. These extra credit points will be formative extra credit points because we haven't given you any chance at a formative extra credit lately to get those points back. Okay? Whereas on the last test, we just had a summative extra credit opportunity. So, yep. Questions on that? Those are be brought into class on Friday. Okay? All right, with that being said, we are in our notes packet. I believe we're on the 6.1 page, I believe it's called. If you're following along, it's page 5 in the note packet. It says 6.1 vectors in the plane. At the start, I would like you to just do a warm-up, and you can either do this warm-up up in the corner, or if you go back a page, there's some open space there, or if you open up your packet all the way to the back end of it, there's a wide open space on the back side. What I would like you to do is I would like you to, 1, draw me a navigation angle of 232 degrees. Then from that, I want you to find me what its corresponding trig angle is, what its corresponding reference angle is. Jose, are you talking to me or are you talking to somebody else? Because it's kind of rude when you start talking and I'm trying to tell you what you need to do. Agree? Okay, let's not be rude. Okay? Right? You need to find its corresponding reference angle, and then you also need to find the Friday angle from Friday's class, north-south with the angle east-west, that form of an angle. Okay? Go for it. So you draw it, and find me the 3 other forms. A 232 degree direction angle would be there. That would leave me a 38 degree angle here, which would happen to be my reference angle. Reference angles come off the horizontal, which would give me a trig angle here of 218 degrees. Which would leave then a 52 degree angle there, which I'm going to need because I'm going down. I'm on the bottom half of my crosshairs, so that would be south. I am 52 degrees off of the vertical, and I am on the west side of the south line, headed in the southwesterly direction. Agree with those 3. Questions on that? Okay. So, then, let's get into vectors in the plane. It's the clip you've all been waiting for.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me. It says I'm committing crimes with both direction and magnitude. Oh yeah!
Okay. So vector is committing crimes with both direction and magnitude. But he's exactly right. A vector is a mathematical quantity, okay, represented by an arrow. Okay? So there's a reason why I chose this to remind Mrs. Hill and Mr. Schmeling that there was a clip up here. Okay? This is a vector. Okay? It's an arrow pointed in a specific direction. Okay? Now, the 2 parts that we have of it are, it's got a magnitude. The magnitude of a vector is its length. Okay? The magnitude is the length of the vector. Okay? The direction of the vector, we're going to go back to trig angles for directions of vectors. Okay? So you are going to have to keep clear, are we talking about vectors or are we talking about navigation? Because those are the 2 different ones that are in this section. Okay? So a vector is used to represent quantities that have both a magnitude, a distance, and a direction. And that direction is the trig angle. Okay? A vector is a directed line segment with its tail. So its tail is where we start. Okay? So the tail is the start of the vector. And the head of the vector is where it ends. And that is where you will also have the arrowhead. Yes, you need to have an arrowhead on your vector if you are drawing it. Okay? Because that's signifying which direction it is going. If we put the head on this end of it, that has a direction that has an acute angle, if you will. Okay? If we switch this around, now the direction angle has changed, and the direction angle is greater than 180 degrees. Okay? Because 0 is straight out to the right. Okay? One of the biggest, I don't know how I want to say this, biggest hiccups, if you will, of a vector is the format of how you write the vector. Okay? Vectors are not written with parentheses. They are not written with brackets. They're written with like big alligator mouths that are, a big old yawn mouth, okay, in between them. Okay? Now, how big of a yawn you give is up to you. Okay? But they need to be like that, not like that. Those mean something else in mathematics. Vectors are kind of the funky brackets. Okay? So a vector has a horizontal component and it has a vertical component. Okay? So the A in this vector would represent how far horizontally the vector goes. The B would represent how far vertically the vector goes. Okay? Both of those make up the component form of a vector. Again, its magnitude is its length. Its direction is from the unit circle. And when we name a vector, we name it with a single letter, and we put a little arrow over the top. You can also name a vector with 2 points. If we had point A and point D, that would tell me that point A is the tail and point D is the head of that vector. It's going left to right just like we read that. Going from point A to point D. I'll give you a second or two here to finish filling in this side. Oh, excuse me. Okay. So we have a rule, especially if we're going between 2 points or 2 known coordinates on the Cartesian coordinate system. It's called the head minus the tail rule. So your vector will have a designated head and a designated tail on the picture for you. Okay? So for instance, if I am at point R, -4, 2, that is my tail. Point S, -1, 6, is the head. So if I'm finding the component form of vector RS, I would then take the horizontal components, the head first minus the tail, so that would be -1 minus -4, and then I would do the same with the vertical components, 6 minus 2. That would give me then the component form of it. Now I just do the math. -1 minus -4 is like -1 plus 4, which is 3. 6 minus 2 is 4. So that would be the component form of R, S, or excuse me, of vector RS would be 3, 4. Okay? You find the component form of vector OP. Vector OP also has a component form of 3, 4, which means that these are then called equivalent vectors. Equivalent vectors have the same component form in them. So therefore they are equivalent. Okay? If it was negative 3, 4, they would not be equivalent vectors. Okay? Questions on that so far? You now show me that RS is equivalent to PQ. Our vector RS, again, had the component form of 3, 4. You show me if it is equivalent to vector PQ. Has the same component form, so therefore they are equivalent. Okay? Let's do some more vector operations. So if vector V is the vector negative 2, 5, okay, so that would have a horizontal component of negative 2 and a vertical component of 5. So vector V then would be right here. Be 2 to the left and 5 up from any point, really. I mean, you could make that go from any point. I just chose the origin just to make it nice and easy. Then vector negative V is going to have all of the same components of vector V, with the exception it is going to be going in the opposite direction. So there's going to be a 180-degree turnaround for it. So it's going to be going backwards through, which puts it 2, 4, nope, one more down here, which puts vector negative V, oops, I went too far, let me erase. Right there. Which would have a component form of positive 2, negative 5. Yes? And their directions would be 180 degrees apart, staying the same magnitude. Okay? So, what's the shortcut for finding inverse vectors, or not inverse vectors, opposite vectors? What do you got? Not reciprocal, because reciprocal would be flipping the fraction. It's staring you right in the face. We don't need to graph them anymore after this, as long as you tell me what it is. What? You just flip the sign, okay? So if you've got vector u as x comma y, then vector negative u, oops, I have to make that be an actual u, then vector negative u would be negative x comma negative y. So we don't have to graph those anymore. Okay? If we have two vectors and we want to add them together, we are going to connect the head of the first to the tail. Oops, I forgot. Talking too fast. To the tail of the second, and so on and so forth. So if you had vector u plus vector v plus vector w, you would then connect the head of u to the tail of v. Then you would connect the head of v to the tail of w, and so on and so forth in that order. Okay? So if I'm going with vector u as now negative 2, 5, negative 2, 2, 4, and 5. So there is vector u. Now then I would start vector v from the head of vector u. Vector v has a horizontal component of 3 and a vertical component of negative 2. So here would be vector v. And where it ends, that is my resultant vector. So this is vector u plus v, which vector u plus vector v then would have a horizontal component of 1 and a vertical component of 3. Yes, ma'am. Find me the shortcut. Keep going.
So then does it, the tail of the last one, we have to start at the tail of the first one?
Mm-hmm. Find me the shortcut. What's up? Add my horizontals and my verticals together. So if vector u is x comma y and vector v is a comma b, oops, see, even I felt trapped to it, then vector u plus vector v would be what? X plus a comma y plus b. Add the verticals, add the horizontals. Make sure your horizontal comes first. Okay. Let's now suppose we have vector v here is 3 comma negative 2. So if vector v here is 3 comma negative 2, there is v. If I have 3v, then that's going to be like vector v plus vector v plus vector v, correct? So then I would go here, it would be another vector v, and here would be another vector v. So I would have my 3 vector v's which then would make vector 3v be 9, comma, negative 6. Is there an easier shortcut method? What do you got? Multiply what? Components by the coefficient? Yep, okay. I like more specific is better. You know what I mean? So if we have vector v here is x comma y, then vector AV is going to be AX comma AY. Agree with that? Yeah. Love it. Ooh. If we've got vector u, and then I've got to subtract off vector v, which means I'm really, vector u minus v is really vector u plus vector negative v. Would you agree with me that u minus v is really u plus negative v? Okay? So then this is really vector u would be negative 2 comma 5, 2, 4, and 5. So there is vector u. Vector v should be 1, 2, 3, 1, 2. Vector v should be right there, but I need to go 180 degrees in the opposite direction. So I'm going to go 1, 2, 3 to the left and up 2. So there is vector negative v. So my vector u minus v would be there. What do we got? Negative 5 and 7. Find me the shortcut. Is there a shortcut? Ethan, what do you got for a shortcut? Just subtract them, right? Subtract your vertical component, subtract your horizontal component. In that specific order, though, right? Okay? So this would be negative 2 minus 3 and 5 minus negative 2. A weird looking 5. Negative 2 minus 3 is my negative 5. 5 minus negative 2 is 7. So again, if we had u is x and y, and v is a and b, then u minus v here is going to be x minus a, comma, y minus b. I will give you 3.5 minutes, because that's all that it took in the last class. 3.5 minutes to find me those 5 values, those 5 vector values. So that's 4 plus 3, that's 7, negative 10, that's negative 19. Negative R. U would be negative 2. Agree with those 5. Yep. Okay. All right. Get into the meat of this stuff now. Let's start figuring out how to find the magnitude of a vector. Again, that's the distance of the vector and the direction angle of the vector. So if I've got vector W here, vector W has a horizontal component of negative 2 and a vertical component of positive 3. That would put it up in here. Do we all agree with that? Yes? Okay. So the distance, the length of that vector then is going to be, let's make a right triangle out of it. Why would I make a right triangle out of that vector? Because now we can use what? Now we can use the Pythagorean theorem. And we have the sides. We know that this side distance here is 2. This side distance here is 3. So I have the Pythagorean theorem. Let's call it C. So I know that C squared is equal to 2 squared plus 3 squared. 2 squared is 4. 3 squared is 9. So C squared here is equal to 13. So C is the square root of 13. So the distance, the magnitude, the length of that vector is the square root of 13. Now, how we write that is we write that as a double absolute value. That is the symbol for the magnitude of a vector. And then the vector's name goes inside of it. Okay? So a double absolute value for magnitude, vector's name inside, and this is the square root of 13. In general, if vector v is of the component form x comma y, then, and this might actually be your next slide, okay? It might be, is it on there? I can't remember. Nope, it's not on there. That's fine. Okay. Then the magnitude of v is going to be the square root of x squared plus y squared. Another reason that we make a right triangle out of that vector, is because then we are allowed to come up with a direction angle. But in order to do that off of that right triangle, I am going to first just find the reference angle for it. Okay? So we're going to find using reference angles, which is why we brought them back earlier. Okay? So, how would I find that reference angle theta prime? In that triangle. What would we use? Or what would you use? Inverse tangent. Okay? So theta prime here would be the inverse tangent of what? Inverse tangent of what? Three over 2. The inverse tangent of 3 over 2 is 56.30993 degrees. But which quadrant are we in? We're in quadrant number 2. Since we're in quadrant number 2, actual theta is equal to what in quadrant number 2? Actual theta is what in quadrant 2? 180 minus theta prime. So 180 degrees minus theta prime gives me an actual theta of 123.69007 degrees. Okay? How we go about writing that then is we would write theta, and then with a subscript, we would write down the name of our vector. Okay? So this is the direction angle for W would be 123.690 degrees. in general, if vector v is of the component form x comma y, then the reference angle is equal to the inverse tangent of y over x, with the caveat that you drop any and all negative signs. You've seen this before. It's the exact same if we were back in when we were doing reference angles in first semester. Okay? Questions, comments, concerns, clarifications? Good a place as any to stop. Again, I remind you that you have now at least through problems number 8 in the homework packet that you picked up today, and you have a formative tomorrow.